So we are going to build a chessboard. As you can see on my screen, we're looking at a chessboard from chess.com. And what we can notice is that we have 8 squares going across, 1, 2, 3, 4, 5, 6, 7, 8, and 8 squares coming down. And it's forming this 8 by 8 square grid that forms the chessboard. The other interesting thing here is that the colors alternate. So we'll go white, brown, white, brown, white, brown, white, brown, and then brown, white, brown, white, brown, white, and that gives us this checkered look to it. So this is actually quite a fun and interesting programming challenge that involves a little bit of math, a little bit of thinking, and we're going to see how it goes. To show you an idea of what we're going to work towards, we're going to build a chessboard, but we're going to add in a little bit of special spice. And that special spice is that we're going to make the chessboard kind of scale and rotate as we move the position of our mouse. So this is like normal, boring chessboard, and then boom, we're going to make it kind of do cool stuff like this, and we'll learn about how all of this is working. Okay, without further ado, let's jump into some code. So there will be a link in the video description to follow along, and let's dive into it. So as always, we want to have our function set up, and we're going to create a canvas. We're going to say 500 by 500, and then function draw. And let's just start very simple, like we usually do. We're going to say background, black, and I'm going to use this command strive.draw tick axes to show us our grid, so we know where everything is. Okay. And now we get a nice, pretty tick axes. Now our task is to get an 8 by 8 grid of squares going, right? So let's start with one square, right? Very simple. Let's just get one square. So we know for a square, we can use rectangle, and a square is just a rectangle with the same width and same height. So let's just put this at 0, 0, and let's put it at like 100 by 100. Okay? Perfect. So we have a square. Now we want the square to go along multiple times, right? Now, one thing that you might notice immediately, right? So if I try and did this, and I said, okay, let's draw another rectangle, and we'll move it across the screen, however which way. We have to make sure that we have enough space and that our rectangles are big enough or small enough such that they're going to fit or take up the full width of our screen. With a width of 100 and a height of 100, for our square, but our canvas is 500 by 500, we can't fit 8 squares into this. We're going to be left with 3 squares left over, because we're going to fill 500, or 5 squares, and we're going to fill 500, and then we're going to have 600, 700, 800. So we need to actually find what the width and height of our squares need to be in order to fit into this grid of 500 by 500. And the easy way to do that is by just saying 500 divided by the number of squares that we want. So we want 8 squares, so it's going to be 500 divided by 8. So 500 divided by 8 comes to 62.5. So it means that the width of each square needs to be 62.5 in order to fit on the screen. So we could say, okay, let square size is equal to 500 divided by 8. But the problem is that if this changes, and all of a sudden this becomes 800, or this becomes 400, this no longer applies. We want our code to be responsive and robust to changes. So the way we can do that is by using a variable instead of hard coding in the number. And we have access to a global variable called width that specifies the width of our canvas. So this, whatever this is, this width variable will be set to that as a global variable that we have access to inside of draw. So now we know we have this size, let's call it square size, and we can create a rectangle with that, right? So I can say 0, 0, and I can say square size for its width and height, and we get a square. Now we want to get the square to get onto, or to fill up the full width, right? So we want to complete this row. So we need to fill in all of these other squares. We know that this point, top left corner, is at 0, 0, right? Now we want another square to form over here. So the top left corner of this square should be where this square ends. And we know that this square ends at 0, 0, plus whatever this width is, which is square size. So we know that this starts over here at rect, right? It'll be 0 plus square size. Let's just say square size here. Square size, 0, square size, square size. Okay? And now we get another square. Okay? And now the next one over here is going to be, we want it at this corner, so it's going to be square size, so twice, 2 times square size. Okay? And so we can copy paste that, and we can put square size times 2. And we know that's going to be the same then for the next one. It's going to be square size times 3. I think I got rid of a bracket over there. It's not looking the most pretty, the code. But there we go. Now we have the 4 squares. But now, this isn't the most efficient way of going about this. Imagine we wanted to get 64 squares. Our grid wasn't 8 by 8, it was 64. You're going to sit here and copy paste each rectangle time by time? It's going to take a while. What we can use is for loops. And we've done a video previously explaining for loops. And let's see how we can use it in this context. So we know that the general syntax for loops, right, is something like this. So if I say for let x is equal to 0, we know we want 8 rectangles, right? So we can say x less than 8, and we can say x plus plus, right? So this over here will repeat this loop 8 times, okay? And we could put rect 0, 0, square size inside of here. Now, the problem is that all of these squares are being drawn on top of one another, so we don't actually see it. We need to move each square onto the next place. We know how to do that, right? We increment each square by square size. So why can't we just do that within the for loop this time? Now, what we want to change here is that instead of putting this less than 8, we want to put it at less than width. We want to fill the whole screen. And we want to say x plus equals square size. And now all of a sudden we're going to fill up an entire row. Oh, we're not, because this is still being drawn at 0, 0. We need to say, okay, draw this at x and 0, square size, square size. And now we get the full row. So that is the first step in getting the grid. The next step in getting the grid is to look at, okay, we have a row completed. How do we get multiple rows to come down, right? We need 8 rows of this now coming down. What we could do, we have one row. Why can't we just copy paste this row multiple times, right? So this is, let's say that this is row 1, right? With y starting at 0. Let's get row 2. And we copy paste that. And now instead of putting it at 0 over here, we want to move them all down, right? Let's just put this at like 100. I don't know why insert was on there. If we put this at 100, let's see what happens. We get another row, perfect, but it's not perfectly aligned with the next one. We want it to start over here. And we know that that y coordinate is just 0, wherever this one starts, plus square size. So we can put square size over here. Okay, and now we get row 2. We could do the same for row 3. Copy paste that. And now we know that it's going to be 2 times square size for where it starts, because we have to go through 2 rows in order to get to this third one. Okay, and we can repeat. But we have the exact same problem that we did with getting the rows to fill up, or getting the squares to fill up one row. And that's, if this becomes 64 by 64, we're going to copy paste this 64 times. It's not very efficient, doesn't work very well. This is kind of a for loop. But now we can think of putting all of this, right? We're repeating the for loop this time. Instead of repeating the rectangle, which is what we repeated last time, we're repeating this entire for loop. So we could think of this for loop, imagine this for loop was just like an instruction that said row, and then filled in the row, and then we'll do a for loop kind of around the row, right? That's one way you can think about this. I'm just doing comments over here in order to show the kind of thinking. So we need to actually do a for loop inside of a for loop in order to do this. So what we want is we want to move down. So we want to say let y, okay, this time. Let y is equal to 0. And we're saying y less than height, okay? And every time we change y, we're going to change it by square size, very similar to this. And so we say y plus equals square size. And now we can simply put this, right, this command, you can think of it as that is just a row over here. This is just saying print a row. But now we always want to print a row moving downwards every time. So let's get rid of these for loops. And what we want to change now is instead of just putting it 0, 0, we want to put this at x, y. And now when we run, if it likes to run, let's see, do we get an error? Unexpected token at line 14. I'm not seeing the error. Let's just try refresh and see if CodePen will be nice to us. Oh, okay, we lost the code. That's not nice. Let's quickly rewrite it. And this gives you a... Okay, so I have found the problem, and it just has to do with the way CodePen, especially when you just do for loops, because CodePen recompiles all the code every time you save, it can sometimes run into problems and run into like an infinite loop if there's a for loop that's written kind of inside of draw, which is another for loop. So just things can go wrong when there's the autosave and it's a syntax error. So a way we can fix that is you can come into settings over here, you go into behavior, and you click so settings, behavior, and you just put this setting, auto update preview, to off, save and close. And now you'll see a run button. Now with the run button, everything will work kind of more predictably and you won't run into weird things like that. So let's bring back all of this good stuff, which is what we're working on. And if we hit run now, we should get one row of squares. Perfect. Okay, we're not getting the other one because this is all still at 0. If we change this to y now, we should get a full grid. Beautiful. Okay, so that is how we can get a grid of squares using for loops. And the cool thing here is that like this number 8 over here is defining how many rows and how many columns there are. If we change this to 64, oh, I need to click run. I'm just waiting for it to go. I changed 64 and click run. Look at that. We now have a grid of 64 by 64 squares just by changing on one number. If I change it to 4, it's going to be a grid of 4 by 4. So that is a useful thing that we've been able to program by kind of using good programming principles. Okay, let's bring it back to 8. And in the next one, we're going to start looking at how to get color.